Good afternoon and welcome to my laboratory. Okay, let's do this. What you're looking at here is another setup to test the claim that the resistance of a Tesla Bifilar wound coil does something unusual. So here I wound a couple of coils, and because the wire I used is so fine, I had to make this little test jig to be able to work with it reasonably. So this is number 34 magnet wire, 380 turns total, and the bifilar side is 190 plus 190. So they both have the same amount of wire. The monofilar termination comes out here to the yellow, and from this end to the black pins. And the two coils are not connected together. I just wound them on the same dowel because it was easier to set up. And the bifilar side has the two parallel windings. Starts with the yellow, goes in, around, and comes out to this red here, which I will eventually connect to this red here, which goes in and around and then comes out to the black. So this is exactly the same as the pancake coil that I showed in the last video, except it's wound as a solenoid. Okay, so once I get done testing continuity and measuring, I will use this little wire here to make the connection between the two reds, which will then complete the series bifilar connection of that solenoid. Okay, and here's the rusty trusty Fluke 87-3 multimeter set on the high precision resistance mode. And so let's test the resistance of the probe leads themselves, and okay, so call it 0.73 ohms. That's the resistance of the wiring right there. Okay, so now let's see if we can test the resistance of the monofilar coil, like so, and that looks like 11.01. 11.001 ohms minus 0.73 ohms for the leads. You have to excuse my math skills here. 1028. 11, yeah, okay, 1028 ohms for the monofilar coil. Now let's do some continuity tests over here to make sure that I'm not fooling you with the windings. Okay, let me zoom in a little bit and change the orientation there. Okay, so let's see. Can you see the pins? We got yellow, red, and black there. So first of all, let's see, I said the yellow goes in, winds around, and comes out to this pin, that red pin here. So let's see if that's actually the case. Go to continuity mode, and doesn't go there, does go there, doesn't go there, and of course the other coil is not connected. Okay, so that's continuity of the yellow winding. Let's get back to high precision mode. Oh. Okay, and backlight. So now let's test the resistance of that winding. This is the single one of the files of the Bifilar coil. 5.91 ohms minus 0.73. It's 5.18 ohms for the first half, and for the second half we'll go to connect to the black lead here and then test continuity. I won't go to the beeper this time, you can just look at the readings. So there, not there, and of course not to the other coil. So from the black to this red we have also 5.91, 5.90, 5.89. Let's call it 5.90 ohms minus 0.73 is 5.17 ohms. Okay, that's for the two individual windings. Now we'll disconnect the meter and I'll use my little wire wrap tool here to make the connection between the reds. There we go, perfect. Perfect wire wrap to make the connection between the reds. Actually, I didn't quite finish it. There we go. Now we will measure the entire coil from the yellow to the black. And we have 11.14 ohms minus 0.73 is 10.41, right? 10.41 ohms. 10.41 ohms for the entire coil. As you can see, the resistance did not go down to half for the Bifilar coil. It's within a few milliohms of the reading of the monofilar coil, and the extra resistance is taken up by the interconnection and the solder joints and so forth in there, which there are more. It's over here there's only 2 solder joints. Here we have 4. That probably accounts for the slightly higher resistance that we found for the Bifilar coil. Okay, thank you for watching.